Ever feel like all the technology we rely on makes us, I don't know, a little vulnerable? Like what if a massive solar storm hit Earth? Imagine no internet, no GPS, maybe even widespread power outages. It'd be like something out of a disaster movie, right? Well, scientists are working hard to prevent that kind of catastrophe. And get this, they're using AI to predict these solar storms before they even happen. So today, we're doing a deep dive into the world of space weather forecasting. And trust me, it's way more fascinating than you might think. We've got a brand new article here, hot off the press, about NJIT, the New Jersey Institute of Technology. They're launching a whole new research center dedicated to using AI for predicting solar storms. And they're serious about it. They just got a $5 million grant from NASA to make it happen. But before we get ahead of ourselves, let's break down the basics. What exactly are we talking about when we say solar storm?
Well, we're actually talking about two main culprits: solar flares and coronal mass ejections, or CMEs for short. Imagine the sun. It's like this giant fiery ball of gas with these incredibly powerful magnetic fields, right? Sometimes those magnetic fields get all tangled up, and then snap, they realign, and that releases a burst of energy. That's a solar flare. Think of it like a sudden flash of light and radiation. Now, a CME is a bit different. It's a massive eruption of plasma and magnetic field. From the sun's corona, that's the outermost layer of its atmosphere. If you picture a solar flare like a flashbulb going off, a CME is more like a cannon firing a giant cloud of charged particles into space.
So both of those, the flares and the CMEs, they can cause some serious problems here on Earth if they're aimed our way, right?
Absolutely. They can interfere with radio communications, disrupt satellite signals. They can even cause power grid failures. Remember the Carrington event back in 1859? Right. That was a massive solar storm. That fried telegraph systems all around the world. Back then, it was mostly just an inconvenience. But if something like that happened today, with our dependence on technology, the consequences would be way worse.
So predicting these solar storms is a pretty big deal. But the article mentions we have a limited understanding of how these eruptions actually happen. What's holding us back from, becoming solar storm whisperers?
It's a bit like trying to predict earthquakes, We know the general forces that are at play, but pinpointing the exact timing and the magnitude of an eruption is still a huge challenge. The sun, it's an incredibly complex system, and there's so many factors influencing its behavior.
One of the biggest challenges is just the sheer amount of data we're dealing with. There are constantly changing magnetic fields, temperatures, plasma flows, all happening on the sun's surface. It's a data deluge, and making sense of it all is incredibly difficult.
So that's where AI comes in, right?
Right.
It can handle those massive amounts of data and maybe even spot patterns that we humans just miss. Exactly. That's where AI becomes really powerful. By analyzing all this data, mountains of data really, from solar observatories, AI can start to pick out these subtle correlations and patterns that humans might never notice. Think of it like, AI is learning to speak the sun's language. It's deciphering these complex signals that precede a major eruption.
It's like having a superpower detective working around the clock to keep us safe from these solar tantrums, huh?
That's a great way to put it. And this NJIT Research Center, they're really pushing the boundaries of what's possible with AI and solar prediction. They're aiming to build this long-term data archive that spans multiple 11-year solar cycles.
Wait, what's a solar cycle? And why is studying multiple cycles so important?
So, the sun goes through these periods of high and low activity in roughly 11-year cycles. During solar maximum, we see more sunspots, solar flares, CMEs. During solar minimum, things are relatively quiet. Now, by studying multiple cycles, we can start to identify these long-term trends and patterns in solar behavior. It's like having a historical record of the sun's mood swings. Gives us valuable clues for predicting future outbursts.
So this data archive is like having a time machine for the sun. We can look back at decades of solar activity and maybe, just maybe, figure out how to predict those future mood swings, as you call them.
Exactly. And this is where AI algorithms really shine. We're talking machine learning and neural networks. They're powerful tools that can sift through all this data and find those hidden gems of insight. Imagine an AI that can tell us, okay, based on the past 3 solar cycles, the next solar maximum is likely to be particularly intense, and we should expect some major flares and CMEs. That's the kind of predictive power we're aiming for.
That's groundbreaking. Not only could this help us prepare for potential disruptions here on Earth, but it could also be crucial for future space exploration missions, right? We wouldn't want to send astronauts on a Mars mission during a period of intense solar activity, would we?
Absolutely not. Understanding the sun's behavior is critical for protecting our astronauts and our technology. both here on Earth and as we venture further into space.
Okay, so we've got this incredible new research center, a massive data archive, and some seriously powerful AI tools. It sounds like we're on the verge of a major breakthrough in space weather forecasting. But I'm curious, how do you actually use AI to predict a solar storm? What kind of data are we talking about?
That's a great question. Let's dive into the nitty-gritty details of how AI tackles this challenge. Imagine you have this giant jigsaw puzzle, but instead of a pretty picture, it represents the sun's activity. Each piece of the puzzle is a different type of data. We have images of the sun's surface from satellites like the Solar Dynamics Observatory, showing sunspots, flares, and those mesmerizing coronal loops. Then there's data on magnetic fields, measured by instruments that can detect the strength and direction of these invisible forces. And we also have data on the solar wind, that constant stream of charged particles flowing from the sun, and information on coronal holes, which are areas of lower density and temperature in the sun's corona.
So it's not just one type of data, it's like a whole symphony of information about the sun.
Yeah.
Now, how does AI make sense of all of this? Does it have a conductor's baton or something?
That's a great analogy. AI acts as the conductor, you see. It brings all these instruments together. Machine learning algorithms, particularly a type called neural networks, excel at finding patterns in these complex data sets. They're trained on vast amounts of historical solar data, learning to identify the subtle correlations between different variables. So let's say a particular combination of magnetic field configurations, sunspot activity, and coronal hole size has historically preceded a major solar flare. The AI can learn this pattern, and then, when it sees a similar combination in the real-time data, it raises a red flag. It says, hey, there's a high probability of a flare brewing.
Wow. It's like the AI is learning to read the sun's fingerprints, identifying the telltale signs of an impending eruption. No. The article also mentioned that this research center, it isn't just focused on predicting storms, they're also training the next generation of space weather experts.
Right. And that's a crucial aspect. We need skilled scientists who can not only develop and refine these AI algorithms, but also interpret the results, understand the limitations of the models, and communicate the findings effectively to policymakers and the public.
That makes sense. AI might be able to crunch the numbers and spot the patterns, but it's the human experts who ultimately have to make the decisions about how to prepare and respond to a potential solar storm.
Exactly. This research center is taking a holistic approach, combining cutting-edge technology with human expertise to create a more resilient future for us all.
I'm really impressed with how NJIT is tackling this challenge, partnering with these big names, NYU, IBM, building a long-term data archive, fostering the next generation of scientists. It's clear they're really committed to making a difference.
It's truly inspiring. And think about the potential benefits. Beyond just predicting solar storms, by understanding the sun's behavior in greater detail, we can gain insights into other stars in the universe, unravel the mysteries of stellar evolution, and perhaps even unlock new sources of energy.
It's amazing how one area of research can have such far-reaching implications. This deep dive has really opened my eyes to the importance of space weather and the role that AI can play in understanding it and predicting it. But before we get too lost in the cosmic implications, let's bring it back down to Earth for a moment. What does this research mean for you and me, for everyday people? How could this potentially impact our lives?
That's a great question. It's easy to think of space weather as something distant and abstract, but its effects can be very real and tangible here on Earth. Think about our reliance on GPS for navigation, not just for our phones, but for airplanes and ships as well. A solar storm can disrupt those signals, leading to inaccuracies and potentially dangerous situations.
Oh, wow. I hadn't even thought about that. So a solar storm could potentially ground flights or cause ships to lose their way?
It is a possibility, although thankfully, we have systems in place to mitigate these risks. But that's just one example. Solar storms can also interfere with radio communications, which are vital for emergency services, aviation, even our daily commutes.
Okay. So we're talking about potential disruptions to transportation and communication. What about power grids? The article mentioned those were vulnerable too, right?
Absolutely. Power grids are particularly susceptible to solar storms because they rely on these long stretches of conductive wires that can act like giant antennas. Picking up the surge of energy from a solar storm, this can overload the system, leading to blackouts. That could affect entire regions.
So we're not just talking about a few flickering lights. We're talking about potential widespread power outages. That could last for hours or even days. That sounds pretty scary.
It is a serious concern. And it's not just about the inconvenience of being without electricity. Imagine hospitals losing power, critical infrastructure shutting down, and the economic losses that would result from businesses being unable to operate.
Okay. This is starting to sound like a real-life disaster movie scenario. But with this new research and these AI-powered predictions, we might have a chance to prepare, right? What kind of things could we do to protect ourselves from the worst effects of a solar storm?
That's the key takeaway here. Forewarned is forearmed. If we know a solar storm is coming, we can take steps to mitigate the impact. Power companies can adjust their grid operations to reduce the risk of overloads. Satellite operators can put their spacecraft into safe modes to protect them from the surge of radiation. And airlines can reroute flights to avoid polar regions, where the effects of solar storms are often most intense.
So it's all about having a plan and having enough lead time to put that plan into action. That's where these AI predictions could be game-changing. The sooner we know a storm is coming, the better prepared we can be.
Exactly. It's like having a weather forecast for space. Just like we check the weather app before we head out for the day. We could have space weather alerts that tell us when to expect solar storms and how severe they might be. This would allow individuals, businesses, and governments to take appropriate precautions.
This is really fascinating stuff. But I have to admit, it's a little bit overwhelming, too. Knowing that there's this potential threat looming out there in space, it makes you realize how interconnected we are, not just with each other, but with the sun and the entire cosmos.
It really does put things into perspective, doesn't it? We often take for granted the stability of our planet and the systems that keep us safe. But space weather is a constant reminder that we are part of a much larger system, and that understanding and respecting the forces at play is crucial for our survival.
It sounds like we've reached a turning point in our understanding of space weather. With AI as our ally, we have a real opportunity to predict and prepare for solar storms, minimizing the disruption to our lives and ensuring a safer future for generations to come.
It's a promising future, and I'm excited to see how this field continues to evolve. Who knows what other incredible discoveries and technological breakthroughs lie ahead?
This has been an incredible journey, hasn't it? We started with a news article about a new research center and ended up exploring the vastness of space, the power of the sun, and the potential of AI to help us understand and navigate this complex cosmic dance.
It's amazing how interconnected everything is, isn't it? From the sun's magnetic fields to the GPS signals guiding our cars, we're all part of this intricate web of energy and information.
And who would have thought that AI, something we often associate with computers and algorithms, could play such a vital role in understanding and predicting something as seemingly distant and powerful as a solar storm?
It's a testament to the power of human ingenuity and our ability to use technology to unravel the mysteries of the universe. And it's just the beginning. Imagine the possibilities as AI continues to evolve and we gather even more data about the sun and other stars.
It's mind-boggling to think about, isn't it? But before we get too carried away with the future, I want to bring it back to our listeners. If someone is interested in learning more about space weather, where should they go? What resources would you recommend?
Well, first and foremost, I'd suggest checking out the NJIT website. They have a wealth of information about the Institute for Space Weather Sciences and their groundbreaking research. And of course, NASA's website is an incredible resource for all things space, including stunning images and videos from the Solar Dynamics Observatory.
Yes, those images are truly mesmerizing. You can literally watch solar flares erupting on the sun's surface in real time. It's a reminder of just how dynamic and powerful our star is.
And it's a reminder that we're constantly learning and adapting to the challenges posed by our cosmic environment. This research is a testament to our resilience and our determination to understand and protect our planet and our future.
Well said. I think that's a perfect note to end on. This has been an eye-opening deep dive, and I hope our listeners are as fascinated by space weather as we are. So keep those minds curious, those eyes on the stars, and remember, even in the vastness of space, knowledge is power. Thanks for joining us on this incredible journey. It's a promising future. I'm excited to see how this field continues to evolve. Who knows what other incredible discoveries and technological breakthroughs lie ahead, right?
This has been an incredible journey, hasn't it? We started with a news article about a new research center, and we ended up exploring the vastness of space, the power of the sun, and the potential of AI to help us understand and navigate this complex cosmic dance.
It's amazing how interconnected everything is, from the sun's magnetic fields to the GPS signals guiding our cars. It's like we're all part of this intricate web of energy and information.
And who would have thought that AI, something we usually associate with computers and algorithms, could play such a vital role in understanding and predicting something as, seemingly distant and powerful as a solar storm.
It really is a testament
Yeah.
to the power of human ingenuity and our ability to use technology to unravel the mysteries of the universe. And this is just the beginning. Imagine the possibilities as AI continues to evolve and we gather even more data about the sun and other stars.
Mind-boggling, isn't it?
It is. But before we get too carried away with the future, let's bring it back down to earth for our listeners. If someone's listening to this and wants to learn more about space weather, where should they go? What resources would you recommend?
Well, first of all, I would suggest checking out the NJIT website. They have tons of information about the Institute for Space Weather Sciences and their groundbreaking research. And of course, NASA's website. It's an incredible resource for all things space. They've got stunning images and videos from the Solar Dynamics Observatory.
Oh, yeah. Those images are mesmerizing. You can actually watch solar flares erupting on the sun's surface in real time.
Yeah.
It really drives home just how dynamic and powerful our star is.
Yeah. And it's a good reminder that we're constantly learning and adapting to the challenges that, our cosmic environment throws at us. This research is a testament to our resilience and our determination to understand and protect our planet and our future.
That's a great point, and I think that's a perfect note to end on. This has been a truly eye-opening deep dive, and I hope our listeners are as fascinated by space weather as we are. So keep those minds curious. Keep your eyes on the stars. And remember, even in the vastness of space, knowledge is power.
Thanks for joining us today.